Hi children, this is Harika. Today I am going to explain a new topic, periodic classification of elements, class 10 CBSE. So let's go into the topic. Periodic classification of elements. Why the elements need to be classified? You have any idea? Okay, let me explain. First, suppose if you go into a supermarket, right? If you go to a supermarket, you find every object or everything which is placed in a neat way, arranged in a neat way, right? So that you can find the thing or the necessary item you want and you can take it. Am I right? If it is fussy or messy, can you take that? No. So if you go to school, for suppose to your schools, so if you see every student was classified according to his age groups from first to 10th. See, we cannot keep all the class students in one room and make them learn, right? It's not possible. It will be very clumsy and messy. So they are classified according to their ages and classes from 1 to 10. In the same way, the elements are also classified because it will be easy for the scientists and as well as the students to study further. So in the classification process, there are scientists have introduced 46 periodic tables. In that, nowadays in present scenario we are using a modern periodic table. What is that, children? Modern periodic table. So it was introduced by Henry Moseley. And among 46 periodic tables, three periodic tables were very famous, like Dobner law of triads, Newland octaves, and Mendeleev's periodic table. So, if you go to Dobner law of triads, which is present in our syllabus, so in the name itself suggests that triads means three elements. In 1816 to 1817, only 30 elements were discovered. So, with those 30 elements, Dobner tried to create a periodic table. So he's a German chemist. He's a Wolfgang Dobner. He told that all the three elements are placed in one group according to the same physical and chemical properties. So in the fundamental thing he used was fundamental property he used in the placing of elements was atomic mass. He used atomic mass as a fundamental property to place an element. He also told that the elements in the same group have the same physical and chemical property. And his principle is that the atomic mass of is the atomic mass of the middle element is equal to the mean of the atomic mass of the first element and the last element. Once again, children, the atomic mass of the middle element is the atomic mean of atomic mass of the first element and the third element. So he told that the atomic mass of the middle element depends upon the mean of the first and third element. So if you see here, uh, lithium, the atomic mass is 7 and the sodium potassium is 39. If you combine lithium and potassium atomic masses and take the mean value or average value, it will be 23, which is the atomic mass of sodium. So he tried to put this principle to every element, but there are demerits as well as drawbacks and limitations in his Dobner law of triads also. What is demerit and drawback and limitation? If scientists were failed to explain the principle or the reason behind the abnormality of his principle, then we call it as demerit or a drawback or a limitation. What is his demerit? Like, he couldn't arrange all the elements according to his principle. Whatever the principle he told, he couldn't arrange all the elements. So that's why this is the demerit or drawback, or we can call it as limitation. Now next we are going to the Newland law of octaves. If you go to the Newland law of octaves, children, if you see here, he is a British chemist. In the year 1864, he introduced Newland law of octaves. So he told that the elements are placed according to the atomic mass. He also used the same principle of fundamental property, atomic mass, and he arranged them in the form of notes. We can say sarigama pada nisa notes are there, no, in music language. So he arranged in that notes. Octaves, octave means 8, waves means 8 notes. So if you see, start from hydrogen, it will end with fluorine. If you see sa ri ga ma pa da ni sa. If I take lithium, let's see, if you go from lithium, sa ri ga ma pa da ni sa. So the first sa starts with lithium and ends with sodium. he told that lithium and sodium has same physical and chemical properties. So this was his basic principle. So he convinced the scientists that lithium and sodium has same physical and chemical properties according to the octaves. So in this periodic table also we have some limitations. So what are those, we'll see. So this principle is only applicable till calcium. So he was failed after calcium. He couldn't even apply this principle. Only till calcium it was very good, this principle was very good. So if you see, it did not leave any gap for the newly discovered elements. If you see previously dominant law of triads, you have 30 elements from which is discovered in 1816 to 17. The scientists were discovering the elements continuously from 16, and here in the year is 64. So approximately as the years passed by, new elements were discovered by the scientists. So the place was not given by this new land for the new elements. So that was the second drawback. And what is the third drawback? Two elements like cobalt and nickel were placed in the same slot. So he introduced these two elements in one slot, which is not possible. So now we are coming to the other periodic table. This is Mendeleev's periodic table, which is the basic which created the base structure for the modern periodic table. He is the first person to introduce the groups and periods which will be there in the modern periodic table. So if you, he is a Dmitry Ivanovich Mendeleev, is a Russian chemist. He arranged the elements based on the fundamental property of atomic mass. He also arranged in the fundamental property called atomic mass, and and he told that according to atomic mass he arranged the elements, and he also told that chemical properties of the similar elements of the similar chemical properties fell into same vertical columns of the periodic table. So he told that these vertical columns have the same chemical properties. So he named them the vertical columns as groups, and he named the horizontal rows as periods. So how many groups are there here, children? 8 groups. And how many periods are there? If you see 1, 2, 3, 4, 5, 6. How many periods? 6 periods and 8 groups. He told that the principle of the Mendeleev's periodic table is physical and chemical properties of the elements are periodic function of their atomic masses. So according to the atomic masses, he arranged, and he told that all the elements which have similar physical and chemical properties are arranged in a vertical column, which are called as groups. So if you see, he left some gaps in between. See, you can find some gaps. What are these gaps? Why he left the gaps? He left the gaps because so that he can when new elements were introduced or discovered, he can place them. So if you see here clearly, below aluminium, he left the gap and he named it as Eka boron. What is that, children? He named it as Eka boron. So he told that is Eka boron element because it is falling in the under the group of boron. So he named it as Eka boron. He thought that the element will have the same physical and chemical property as boron. Later the Eka boron is named as, you can see here, this scandium. What is that, children? Scandium. And in the same way, below Eka boron, he named it as Eka aluminium. What is that, children? Eka aluminium. And beside Eka aluminium, he named it as Eka silicon. Eka silicon. So he left the gaps for the introduction of new elements. What elements, children? For the introducing new elements. In the same way, in the place of Eka boron, new element were discovered called scandium. In the place of Eka aluminium, new element were discovered known as silicon. In the place of Eka silicon, the new element were placed called germanium. So he was very anticipating and optimistic scientist, we can guess like that. So because he left some gaps for the discovering of new elements, and he discovered the noble gases. Noble gases were discovered in his time. So he observed that noble gases all have same properties, like they are not reacting with anyone and they are very stable. He observed that all the properties of physical and chemical properties of these noble gases are same. So he thought of not to disturb this periodic table, and he thought to place the noble gases in separate group. So he doesn't want to disturb this existing order. So he placed in the other ninth group. We can say ninth group. So this is the Mendeleev's periodic table. So now we will see what are the we can say what are the limitations we can see in the Mendeleev's periodic table. He was unable to locate the hydrogen element in the periodic table because hydrogen behaved very peculiarly. It behaved like alkali metal and it behaved like a halogen also. As it contains only one hydrogen, it will be like as one sorry it contains only one electron. It will be behaving both like an halogen as well as alkali. So it was very confused for the scientists to place it whether in an alkali side group or in a halogen group. So he that was the first demerit, and the second was he couldn't at increase in the atomic was not regular while moving from one element to other element. Like for suppose you told that what is the element which comes after 126, it comes 127, right? But in some of these table he told 127 after 126, like that he changed the increasing order was not mentioned. So he also told that isotopes of the elements were found which were violated the Mendeleev's periodic table. If you see isotopes, see you already know. So isotopes in the sense how the atomic how the periodic table was placed for Mendeleev's depending upon the atomic masses, right? So if depending upon the atomic masses, see for carbon C6, what is the isotope of carbon? This is original form of carbon. What is isotope C6? 14. So if you see the original carbon is C612 and the isotope of carbon is C614. If you see the mass number is differing here. Am I right? This is 14. Here is 12 and here is 14. So if you see the difference, these cannot be placed in the periodic table. As his fundamental property of the periodic table is atomic masses, this also should be placed. So he did not place in the periodic table. So here it was deferred. So these are the three limitations of the Mendeleev's periodic table. So now if we go to that present day, we are using what is that, children? Modern periodic table, long form periodic table, which was introduced by Moseley. In the year 1913, Henry studied the frequencies of X-rays. Accidentally it was happened. So he was studying the frequencies of X-rays. What is the X-rays nature? Which are emitted from certain metals. So these X-rays are emitted by certain metals. So which are emitted by certain metals by bombarded with high-speed electrons. These X-rays are bombarded with high-speed electrons. He found in all the cases the square root of the frequency is directly proportional to the atomic number of an atom. So he told that the frequency is directly proportional. Square root of the frequency is directly proportional to the atomic number. Then he came to know atomic mass is not the atomic mass is a fundamental property only, but it does not have a great significance to make a periodic table or to introduce a periodic table. So he thought that atomic number is the crucial one, more accurate one to create a periodic table according to the atomic number. So these studies believe that atomic number is a fundamental property of an element. So he came to know that not the atomic mass, but the atomic number is a fundamental property of an element. So in the above observation, Moseley gave modern periodic law which states that physical and chemical properties of the elements are the periodic function of their atomic number but not the masses. So he told it is the what is atomic number is the fundamental property of the element of an atom. Also it is the fundamental thing to create a periodic table. So he named periodic table. If you see here, he named with groups in the same how Mendeleev introduced groups and periods, right? In the same way he also continued the same, but he took there are like how many groups? 8 groups plus one ninth group is halogen sorry noble gases group, and 6 periods, right? But here he introduced 18 groups and 7 periods. So if you see here, children, group 1 to group 18 we can see alkali metals, alkaline earth metals. Group 2, group 13 is boron family, carbon family 14 is a carbon family and 15 is a nitrogen, 16 is oxygen family or a chalcogens, and 17 is a halogen family or group of salts. 18 is a zero group and noble gases. Noble gases. So now if you see children, in the arrangement, so the first period has two elements. See, hydrogen is finally placed in the alkali side, and it has two elements. The first period has two elements. What is that? If you see here, the first one is hydrogen and the second one is helium. So again, if you see the second and third elements, you have eight elements. So lithium to neon, we have how many elements? Eight elements. So in the fourth and fifth, we have 18 elements. So in the same way, sixth and seventh, we have 32 elements. So first one, we have how many elements, children? 2. So the second and third, we have how many elements, children? 8. And from fourth and fifth, we have how many elements, children? 18 elements. So from here, like sixth and seventh, we have how many elements? 32 elements. So he also told that he also told in sixth and seventh periods, from lanthanum he named as lanthanides, for actinium he named as actinides. These lanthanum are rare earth elements, whereas from actinium these are radioactive elements. So he told that from 57 there are rare earth elements, from 89 it is radioactive elements. And he also created groups, children. See what are the groups, we'll see. Okay, he named the groups as blocks. Okay, now we'll see. See, these two are, like he told that these two groups are S block. What is that, children? They are S block. And he told that from boron to helium, it is a P block. What block, children? P block. And he named this is a D block. And the last one is, he named the last one as F block. Why the names are given? Why is it so? What is the significance for giving scientists these names? Because these we can say in the periodic table there are, like we can the classification is based on the type of orbitals, see, that contains the balance of electrons of the element. So if you take hydrogen, the last element or the valence electron stays in the s orbital. That's why hydrogen is placed in S block. What block, children? That is S block. So in the same way, lithium, if you take lithium also, so it last element or valence electron placed in the s orbital. That's why it is placed in S block. It is like, what is the atomic number of the lithium, children? 3. Like if you take lithium, 1s2, 2s2, sorry, 1s2, 2s1. So valence electron stayed in the s orbital. That's why it is placed in the S block. Now if you are going to the P block, what block, children? Now we are going to the P block. If you go to the P block, all the valence electrons are placed in the P shell. All the valence electrons are placed in the P shell. That's why it is named as P block. What block, children? P block. Okay. Now in the same way, this also all the valence electrons stay placed in the D block. That's why D orbital. That's why we call it as D block elements. In the same way, all the elements are placed in the F orbital. That's why it is called F block elements. And this is also called lanthanides and actinides. We can say this is 4F and 5F series. If you see here clearly, children, there are 18 vertical groups. How many vertical groups, children? See clearly. 18 vertical groups, like vertical groups in the sense 1, 2, so on till 18. And we have 7 horizontal periods. 1, 2, 3, 4, 5, 6, 7. How many horizontal periods, Nana? 7 horizontal periods. So he named as vertical groups as, he named vertical columns as groups and horizontal rows as periods. So that was the explanation given by the modern periodic table. So if you go to the next topic called valency. So according to the periodic table given by the Mosley, there were properties formed depending upon the periodic table. Now first we'll know about the valency. What is valency? The number of electrons present in the outermost shell or number of electrons that can be lost or gained during chemical reaction. For suppose, see, every element in the periodic table want to behave like a noble gases. See, these noble gases have octet configuration. In previous classes, in previous chapters, you will know this. So, what is octet configuration? It is a stable configuration of an atom or stable configuration of an element. Every element of these periodic table want to behave like a noble gases. So why they want to behave like noble gases? Because they want to have a stable configuration. They want to have a stable lifestyle, we can say, if we apply to mankind. So that's why it will like these elements will try to lose electrons. Some elements will try to gain electrons. In either gaining or losing, they want to obtain a stable octet configuration like noble gases, because they want to stay stable. In the staying of stable, the elements will combine, elements will lose electrons or gains electrons. So in the same way, the valency means the number of electrons present in the outermost shell. In chemical reactions, mainly the outermost electrons which is placed in the valency shell will be playing a crucial role, because the electrons which are placed far behind will have less nuclear attraction. That's why they will be playing the crucial role in chemical reactions. Now, periodic properties we will know, children. What are the periodic properties depending upon the modern periodic table? The first one is atomic size, second one is ionization enthalpy, third one is metallic character or electropositivity, and the fourth one is non-metallic or electronegativity. So you can see in this table atomic size of elements in the periodic table. If you see from top to bottom, the atomic size is increased. From left to right, the atomic size is decreased. Now let's go to the first property, atomic size. See, if you see, children, the distance between the center. So I'll tell you, wait. What is that, Nana? The distance between the center and the outermost orbit is called atomic size. So distance between the nucleus, we can call center or nucleus, and the outermost shell is called atomic size. From left to right, if you see from left to right, the atomic size is increasing or decreasing? See, decreasing, no? Why it is decreasing? As number of electron increases, see, and it has a more nuclear attraction towards the nucleus, so the size is decreased. So in the same way, from top to bottom, the atomic size increasing or decreasing? Here it is increasing. So the atomic size is increasing from top to bottom and decreasing from left to right. What is atomic distance between nucleus and outermost orbital is called atomic size. This is the first property. Now let's go to ionization enthalpy. What is ionization enthalpy? The minimum amount of energy, listen carefully, the minimum amount of energy required to remove an electron from outermost shell or valency shell is called ionization enthalpy. So if you see here, the distance between the nucleus and the outermost shell is big or small? Very big, right? And very large. If you see for fluorine, the distance between the nucleus and outermost shell is less or more? Very, very less. So if you see, children, when the person is far behind you, can you pull the person? He's very, very far distance from you. Can you pull the person? No, you cannot pull the person. But whereas when the he's from far, you cannot pull the person. But the person is very, very near to you. So if you know tug of war fight, there will be children will be playing. So if you catch the person at this point, you can clearly see you cannot hold the person. So it will be easy. That opposite person will be easily slipped away. So if you hold the persons with like till elbow, you can drag the person very easily, because you are holding three-fourth of the hand of the person. So you can drag him very easily. In the same way, see, here the electrons are placed in the outermost shell with a large distance. The nucleus attraction towards the electrons is very less. That's why the nucleus will be, that's why the electron will be, in this element will be losing. Whereas here in the fluorine side or lower atomic size element side, if you can find that electrons will be very near to the nucleus. It is very hard for the other element to drag the electron from its outer shell. Though that is the reason why the atomic size, where like if you have more atomic size, the ionization enthalpy is very, very less. It will be easily removed. So if you go to fluorine side or lower atomic size side, it is very hard to remove an electron. So what is ionization enthalpy here? Again we have, again if we see minimum amount of energy to require remove an electron. So how much of energy is required to remove electron from the atomic element which have atomic size very big? Very less amount, because you can drag very easily, because you are holding the person the tip, so it's very easy to remove. So minimum amount of energy means very less energy to remove electron from the outermost shell in the elements having higher atomic size. In the same way, if you want to remove an electron from here, can you remove? No, you cannot remove. So because they have very much of nuclear attraction, we cannot remove from it. It requires much amount of ionization enthalpy. So that's why it is very hard to remove. It has more ionization enthalpy. So if you see atomic relation between the ionization enthalpy and atomic size, they are inversely proportional. So ionization enthalpy is inversely proportional to atomic size. So if it is inversely proportional means the properties differs here. So from left to right, I increases or decreases? It increases, because as the size is decreasing, ionization enthalpy is increasing. As the size is decreasing, what will happen? It will have a great nuclear force of attraction, and it will have more energy to remove the electron. As it has more energy means it is a more ionization energy. So second one is the from top to bottom IE decreases. From top to bottom the IE decreases. Why it will be decreased, children? See, the hydrogen atomic size is very less than the lithium atomic size. In the same way sodium, am I right? So if you the size increases means what is happening here? Ionization enthalpy decreasing. As the size is big, it is very easy, and it is requires very less amount of energy to remove an electron from the outermost shell of an atom. So that's why ionization enthalpy is very low here. Okay. Now next go to the metallic character of an element, or we can say metallic character electropositivity. Okay children, so what is a metallic character, madam? If you can see, all the elements are not metals, all the elements are like metals, all the elements are not metals, and the same way as all the elements are not metals. See, if oxygen is a metal, you cannot breathe a metal oxygen, am I right? You can only breathe oxygen which is a non-metal. In the same way, if gold is a non-metal, you cannot wear it as an ornament, am I right? So depending upon the electronic configurations, electronic placements, chemical reactions, and the properties, the metallic character will be changing, children. So metallic character will be obtaining by the element. So if you see, the ability of an element to lose electron is called electropositivity. So element is, electron is negative and proton is positive. So if you have equal number of electrons and protons, one minus will be gone, means we'll get what we will show, children? We'll say positive sign will be shown. Why the positive sign? In class also, if we have like three boys and you have three girls, how many, Nana? Three boys and three girls. What you will say? We have three boys and three girls, ma'am. So if you take minus one, so one girl left the class. What you will say? Three boys and two girls. Am I right? So how you can define it? How, which one is more here? Boys are more here. In the same way, element in the atom also, we have equal number of electrons and equal number of protons. What is that, children? Equal number of electrons and equal number of protons. If you take electron as negative, proton as positive, so if the electron goes away, number of protons, as number of protons increases, then we automatically will signify that element with positive, Nana. That's why the positive electron. That's why here electropositivity came here. Okay, did you understand? Okay, now let's go. The ability of an atom to lose electron. So you can clearly say, as you have already known here, to lose electron. Which element, which atom have the tendency to lose electron? Which will be losing very easily. If you catch here, you will lose very easily. No, if you are catching here means it is very far away from the nucleus. Far away from the nucleus means distance between the nucleus and the valence shell is very more. Okay, it's clear. So you can say that which is directly proportional to the atomic size. So it here the relation between the electropositivity and the atomic size is directly proportional. If you see, the bigger the atomic size, the same will be the electropositivity. So if you see children, the ability to lose an electron means, see, hydrogen loses electrons, then hydrogen lithium loses electron, then lithium sodium loses electron more easily. So if you go from left to right, EP decreases. So from lithium loses electron easily, beryllium, okay, it will lose normally. And if you go like the same way till boron, carbon, nitrogen, it will be decreased. So whereas from fluorine it will have, it is impossible to remove an electron from the fluorine. In the same way, if you go from top to bottom, the EP increases, electropositive nature of an element increases. Because why? See, it is what is that principal ability of an element to lose electron, right? It automatically size increasing means attraction decreases, automatically they lose electrons very easily. Am I clear so far? Now let's go to the non-metallic character or electronegativity. What is that, children? Electronegativity. Now again come to the topic. So negativity, what it is showing? Negativity in the sense the electrons are more here and the protons are less here. Protons are less in the elements, means electrons are decreasing and the protons are electrons are increasing and protons are decreasing. So why electrons are increasing? What is the happening here? I already told you, every atom want to behave like a noble gas and everyone want to behave like a want to have like a noble octet configuration, noble gas chemical and physical properties. I want to have an octet configuration. If you see in the electronegativity, negative sign will be increasing. That's why it is called we call it as electronegativity. It is also known as non-metallic character. What is that non-metallic character? The ability to gain electrons is called electropositivity. The ability to gain electrons is called electropositivity. So if you see in this atom, in hydrogen or lithium atom, you cannot it cannot hold the electrons which is present inside. How can it gain other electrons? Am I right? it, Actually it is not even holding the electron which is present within it. How can it gain other electron? It cannot have energy, right? If you see here fluorine, it will not leave the electron very fastly. Why? Indeed it will gain the electron. Why? Because the size is less and the attraction is more, so it will always try to drag the electron and will have a octet configuration of neon, which is a noble gas. So in the same way chlorine also, it will also want one electron and have a octet configuration of argon. If you see oxygen will attract two electrons and want to have a neon configuration. In the same way sulfur also, children. So electropositivity means the ability to gain electrons is called electropositivity, which is inversely proportional to atomic size. This is inversely proportional. So if you see here, sorry, electronegativity. If you see here, from left to right, the electronegativity increases. What happens to it? Increases as size decreasing, electronegativity increasing. And from top to bottom, it is as size increasing, electronegativity decreases. So if you see here, the electronegativity of lithium is very less compared to the fluorine. Electronegativity of potassium is very less compared to bromine. So why? As size is decreasing, the attraction towards the nucleus will be more and it will be like gaining the electrons more frequently rather than the alkaline metals and other metals also. So there are some exceptions here also you can find, but this is the property we can find in the we can find in our modern periodic table. With this we complete our class, children, and thank you.